Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is using the ITX convert function to sanitize data. Feel free to reach out to me on popular social media channels at Paul Brett IBM. The convert function uses an ASCII positioning table to return a character from the position from the original hex value. So, for an example, the capital letter C is a hex 43. If we look at the table on the left, you can look down to the fifth row labelled 40H, move along to the fourth character along, that's 0, 1, 2 and 3, giving you the 4-3 position. As you can see, it returns a capital letter C as highlighted in the red box. However, the convert function, when given the table on the right, will return a capital letter A because that is what is in that position. A second example, the lower letter K in hex is 6B, so we look at the seventh row down, labelled 60H, and we look at the 11th character across, and we get a lowercase k. However, in the table that we're presenting to the convert function, what we get back is a lowercase a. Final example, the number 8. In hex 38. We look at the fourth row, labelled 30H, across at the 9th character, and we get an 8 returned on a normal ASCII table. However, with the custom table that we present to the convert function, we get back the number 0. Having a look at the custom table, you can see that for every number position, a 0 is returned. For every capital letter, an A is returned in capitals. And for every lowercase letter, an A is returned in lowercase. This is how we are using the convert function to sanitize data. Let's move on to the demonstration. We're going to start this demonstration in my design studio, where I have created a project called Sanitise. Within Sanitise I have 3 files, input.txt, sanitizetable.txt and a generic type tree, generic.mtt. A quick look at the input file. You can see that I have 3 lines saying this is a secret message with an account number and then an account number in brackets, followed by some more text and some other secret stuff. My sanitized table I'm going to open in Ultra Edit. It looks a bit weird at first, but if I switch to hex mode, you will see the same table that you saw in the previous slide. Every position has a byte filled in to indicate its actual position within the 256 array. So at position 00 we have byte 00, in position 01 we have byte 01, and so on and so forth. However, the only difference being that in place of all the numbers, we have the hex sequence 30 to represent a single 0. In place of all the capital letters, we have a hex sequence 41 representing a capital letter A, and in place of all the lowercase letters, we have a hex sequence 61 to represent the lowercase letter A. Every other byte remains the same. Let's close that for a moment and let's build our map. I've created a map source file called example.mms. Now I'm going to actually create a map within it. The map is created. I now need to create 2 input cards. The first of these 2 input cards is called input. I'm going to use the generic.mtt type tree, and from within that I'm going to use the text item object. The file I'm going to read is input.txt. My second card I'm going to call ASCII table. Again, I'm going to use the generic text item object, and this time I'm reading the file sanitizetable.txt. So there's my 2 input cards. Next thing I need to create is an output card. My output card is called out. I'm using the same type tree again, and I'm writing to a file called output.txt. Okay, let's populate the output card with a rule. We're going to use the convert function. The first argument to the convert function is the input file that we're going to read, And the second argument is going to be the ASCII table that it reads to pick out the characters for each of the input characters. So the map is complete, so let's save, build and run our map. The map has completed successfully, and here we have a look under miscellaneous. We'll see we have an output.txt, and if we open that, you will see that the input string has been converted and sanitized. Bring up the input file again just to show you the differences. We have every character is in exactly the same position, but it's been converted to either capital A's, lowercase a's, or the number 0. So in theory, this data would fulfill the same type tree that another map might need, but the data itself is no longer subject to GDPR restrictions, for example. So there we go, a quick demonstration of how to use the convert function to sanitize data. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button and perhaps leave a comment. Consider subscribing to my YouTube channel as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.